Good evening, everybody. We're going to start the session, and I do want to remind you that this is being recorded. So tonight we're doing a second free demo of the Proactive Testing Risk-Based Test Design course. And tonight we're going to be looking at Proactive Testing Lifecycle. So as you know, if you attended last time, we start each session with a brief recap of the prior module. And so in yesterday's session, we talked about processes and the difference between real processes that actually produce our results and presumed processes that people think are producing our results. And that if the presumed process is not the same as the real process, when people try to change it, they don't typically get the desired improvements. And we talked about typical testing experiences, which unfortunately are that our software development and testing process kind of routinely delivers trouble, partly because of misestimating how long the development is going to take and not allocating sufficient time, resources, or knowledge for testing. We talked about the fact that errors are easier to fix the earlier that they are found, and that unfortunately most folks tend to find them far later and don't have a good measure of where their errors come from, how many of them they have, and what it's costing them to fix them. And then we made some distinctions between being reactive and proactive testing. And traditional testing is reactive. It reacts largely to the system that is built. Proactive testing lets testing drive development and uses a variety of approaches that generally produce far superior results. So tonight we're going to be talking also about the exercise that I asked you to do. Hopefully some of you have thought this out. So even if your organization does not have it formalized, there's usually some kind of a way that you regularly go about doing testing. And so I asked you to briefly describe the sequence of steps that would be in your defined process, your organization's defined process. And I think you'll find that simply the act of thinking about this and writing it down is going to help you understand more about testing and more about how some of these methods and concepts that we're talking about might be applied in your own environment. So some typical answers. And I will tell you that I've kind of put together a brief summary of some common answers that students give in a live class or in an in-person class. So for instance, you receive the system design information, you create tests, you construct test data, you execute the tests, report defects, you're probably going to find defects, and you run regression tests. And regression tests are rerunning tests to make sure that things that were broken have been fixed and things that were not broken do not get broken. And I'm sure that some of you have similar processes. You may have some things different. You may not have included each of these. But let me point out some other things, some real process stuff. So what are the chances that the information that you receive is inadequate, late, or wrong? Okay. That's a very common experience that many testers get. We had a question last night about what do you do when you've got to deal with that. And we'll be addressing that to some extent within the proactive testing methodology and techniques. There's a good chance that by the time that you get involved, you're already late and you don't have time to create sufficient tests. One of the most frustrating experiences that testers encounter is that they find a defect, they report it, and the developers say, oh no, that's not a defect. It's coded as designed or something to that effect. And it may or may not actually be a defect, and if it is, then you're getting into some finger pointing and some arguing, what's called defect advocacy, but it can be an uncomfortable time. Another thing that happens, of course, is that the requirements change, and when the requirements change, that means you're going to have to add and change tests, and Alex says it's a feature. Yes, an undocumented feature, something that we didn't expect. And then out of all of this, it's very common that the testing gets cut short because the whole development process is late and you're trying to hit a deadline that was probably not realistic in the first place. So if your perception of your testing process is only the things on the left, then those are the things you're going to try to improve upon. But if the things on the right are also part of your real testing process and you're not acknowledging them and dealing with them appropriately, you're going to continue having frustrations. So when we get proactive, first thing that we want to do is make sure that we understand what the real testing process is, not just the presumed process, not just a desired process. So tonight, we're going to talk about some keys to effective testing. I'm going to introduce you to a technique that I call the CAT scan approach. And we'll talk about some models of development and testing, specifically what's called the VModel, which is a fairly well-known model of testing. And then we're going to look at what I call the proactive testing life cycle. And I think you'll find that it is helpful to see it as a life cycle, to see it all together, and that it makes sense. And then at the end of the session, I'm going to give you an exercise on WIFMs, the what's in it for me's, something that proactive testing puts a lot of attention upon, finding things that other people, the people whose behavior we want to affect, that they think, that they find saves them their time, their effort, their aggravation. Now I know we're well past Christmas, but I like to remind people that Santa Claus knows the two most important things about testing: making a list and checking it twice. And that's what testing does. Testing is making a list. That's your test plans and test designs and test cases. And then you're checking it twice. You're checking against what's been developed. And that's how testing adds value and finds problems. So we've got a number of keys to effective testing. The first one is that you need to define correctness independently of actual results. So let me put this in a little bit different context. When you run a test, you get actual results of the test. What do you compare those actual results to? You compare them to expected results. Expected results are your definition of correctness. In other words, the results you expect are what will happen if the system or program is working correctly. Now, if you have not defined your expected results and you run a test and get actual results, what are you going to assume the expected results are? You're going to fall into the trap of assuming that whatever you got must be right. In other words, that test is a waste of time. If you run the test, get the actual results, and then try to figure out what the expected results are before you compare them, you're still probably going to fall into the trap of expecting only what you've gotten. So you need to define correctness, expected results, independently of your actual results, and preferably before you get the actual results. And by the way, when you do that, you've got to know what the right answer is. This is not arbitrary. You have to define expected results that in fact are right. And then you need to systematically compare the actual results that you got to the expected results. And I will tell you that there are many people that run tests and don't actually check whether the results they got were the ones that they were expecting. And they can miss a lot of problems that way. So you need to make these concepts conscious and explicit. That's going to make your testing more effective. Now there's one other key here. That's following independent guidelines. I'm sure you're familiar with things falling through the cracks, overlooking things. Well, the key, or a key technique for avoiding overlooking things, is to follow independent guidelines, things that exist for some other purpose that help you know what to look for. So for instance, if you've ever gone shopping at the supermarket and gone without a shopping list, you know that you come home with a much different situation than if you go with a shopping list. When you go without the shopping list, you end up buying more and often forgetting the things that you actually went to go shopping for. So your shopping list is an independent guideline that helps you know what to buy. Let's look at an example. So let's say that you've entered customer number 123. The result comes back John P. Jones. Now, is that right? Well, you've got to know what the right answer is. It should be Jones, John P. period. So I think you can see how easy it is to fall into the trap of assuming that the actual result is correct if you don't have a really good idea of what the right answer is supposed to be. Similarly, you enter a new customer's name and address. The screen comes back with fields cleared, ready for entry of the next value. Right or wrong? Oh, it's supposed to say added. You buy 10 widgets for $14.99. Right or wrong? Looks right, but you got to know the right answer. And there's also tax on that. Now, I think in these simple examples, you can see how easy it is to fall into these traps. These are traps that experienced testers and inexperienced testers fall into them even more. The key to not falling into these traps is to make these concepts conscious and explicit. I'm sure that some of you are familiar with the term CAT scan. It's a medical technique. It's an alternative to an X-ray. An X-ray takes a two-dimensional image. A CAT scan takes a three-dimensional image. Let's say that your shoulder hurts. You go to the doctor sends you to the hospital sends you to the radiology department, and they take an X-ray. The radiologist looks at it and sees no reason why your shoulder hurts. What if they take that X-ray again? Will they see anything different? Probably not, unless they had their finger over the lens or something. What if they try harder? Well, once again, they're probably not going to see anything different unless they didn't try hard enough to push the button to make the X-ray take its image. American management, and frankly worldwide, management's two most common reactions to difficulties are do it over and try harder. And doing it over and trying harder are not going to make any difference most of the time. What if instead we did a CAT scan? Now, the way that a CAT scan works is that it takes two-dimensional images from many different angles. And then it pieces them together through the magic of computers, but this actually works, to give the appearance of a three-dimensional image. Now, the thing about the CAT scan is that each CAT scan angle, each different angle that it takes, has the opportunity to reveal something that was not observable from some other angle. And so we use this concept in testing, that if you're not finding something one way, don't just keep doing it or trying harder. Take a different CAT scan angle. And we can plan multiple CAT scan angles. And as we go forward in executing tests, if we need to make any changes, we do it by looking at different additional CAT scan angles. So there are a number of ways to characterize testing. One of those is the distinction between dynamic testing and static testing. Dynamic testing is actually executing the thing that you're testing. Static testing is anything short of that. Now, dynamic testing is the most powerful testing. It's also the most expensive type of testing, and you can't do it until relatively late in the development process until you have something that's executable. Static testing falls into two categories, passive and active. Passive static testing is the least powerful, but the easiest and the cheapest type of testing, and the type of testing that typically can be done earliest. So, and active static testing is more powerful, sometimes as powerful as dynamic testing, but can be done earlier and cheaper. And so when we organize our testing, we want to use multiple CAT scans, multiple approaches, and by the way, varying degrees of formality are also different CAT scans. The more formal you are, the more powerful, but the more expensive the testing is. The less formal, the easier and earlier you can do it, but the less powerful it is. But each of these techniques represents a different CAT scan. And so when we plan and organize our testing, we try to use a variety of these approaches, especially static approaches, so we can catch more of the problems earlier when they're easier and cheaper to fix. I mentioned the VModel. The VModel was the first model of development that gave real visibility to testing. The VModel says that there is an orderly sequence in which we develop systems. We start with business or user requirements, define a high-level design to address them, then drive that down to a low-level design. That is what is coded. And then unit tests are testing the smallest pieces of executable code. Unit tests are typically referred to as code-based tests. And when unit tests work, then we put them together into integrations. We combine them, along with possibly other integrations that have been tested. Integration tests are testing low-level design, primarily interfaces between the various pieces. And then the biggest integration is the system test, an end-to-end test in a production-like environment. And the system test is testing high-level design, major features and functions. Unit testing, integration testing, and system testing are what I call technical or developmental testing. They are the responsibility of the development side of the house, which, by the way, includes QA and testing. When the development side thinks that the system is working properly, then it goes to the users for user acceptance testing. And what user acceptance testing is doing, or should be doing, is testing that what the development side of the house thought they ought to do is in fact what the business actually needs. Once again, each of these represents a different CAT scan. Each is going to find different things. Each has different objectives. Unit tests are typically done by developers. And because of that, when a developer finds one of his or her own defects, he or she just goes ahead and fixes it. Defects that are found by developers are referred to as private defects because only the developer knows about them, and frankly, the developer tends not to pay attention to them and just goes on and fixes them and continues on and doesn't have a whole lot of awareness of the defects or how many he or she has had. Higher level tests, like integration tests, when they find the defect, it's usually found by somebody other than the developer. So it's referred to as a public defect because it's known by somebody else and it needs to be reported back to the developer. So here's a very simplistic example. We've got two modules. Module 1 takes in a date and validates it. 30 days have September and so forth. Module 2 takes a date and exercises a bunch of business rules against it. So we could have a unit test for Module 1, we could have a unit test for Module 2. And then we could have an integration test of the two of them by entering a date in Module 1 and feeding it into Module 2. Now in the traditional teaching of testing, people act as if there's a real hard and fast distinction between unit tests and integration tests. The fact is it's a very blurred line. And while developers do unit tests, developers also do a lot of integration tests and don't differentiate them from their unit tests. And then we have a couple of types of tests that are end-to-end tests of the full system. Now, these are often done at the end, but I will encourage you, and we'll see how we can do this later in the course, that you can do these in more gradual steps and also do them earlier than at the end. So system testing is the province of the development side of the house. It's demonstrating that the system works in a production-like environment. System testing, many people think, also means doing what are called special or environmental tests, things like performance testing, security testing. Technically, they are separate from system testing, but they are often performed as part of system testing. And then there's this other creature called a QA test, and some of you may be familiar with that term. Many organizations have what they call a QA test, which is performed by a separate independent QA or testing group, and generally it's the only thing that that QA or testing group does, and it's a big final test, the last thing before the code goes out to the users. And then users are responsible for and have the opportunity to do acceptance testing. And acceptance testing is there to demonstrate that the system works when used in a manner similar to the way it will actually be used by real users. Now, each of these is a separate CAT scan. Surprise, surprise. If you do one of them, you're not going to find as much as if you do two or if you do three. But the more that you do, the more expensive they are. So there are trade-offs. A lot of people, without realizing it, try to save time by consolidating things, and they end up shortchanging themselves. So it's very common that organizations want users to do the system test. Well, that presents a problem for a variety of reasons. One of which is that users do not understand the system from a system perspective. They're not going to do as good a system test. The other thing is that when they're busy thinking about it as a system test, they're essentially eliminating their ability to test from an acceptance testing standpoint. Some organizations have QA or testing do the system test. QA and testing people tend not to think quite the same way that developers do. They're not going to address it quite the same way, but they'll be better testers typically. And many organizations expect QA or testing people to do acceptance testing, and QA and testing people just don't think and act the same way that real users do. And some organizations have the developers do the acceptance test, and that's sort of like the fox guarding the chicken coop. Yesterday, some people asked about agile development. The typical way that user acceptance testing is done in an agile project is that the development team demonstrates the system to the users. Now, if you've ever been in a system demonstration, you know that when it's being demoed, it seems to work fine. And then when you try and use it yourself, sometimes that doesn't come true. So it's not just using these different approaches, but it's also how you use them and who does them. So I want to spend the bulk of what we're doing describing to you what I call the proactive testing life cycle. And a life cycle is a set of steps or phases that have been found to lead to success in some endeavor, such as development. And so I've pictured in the yellow boxes, the solid yellow boxes, the various development life cycle phases. If you follow the life cycle, if you do the phases in the proven sequence, it tends to increase your chances of success. If you skip a phase or do things out of sequence, it tends to increase your chances of failure. So simply knowing about the life cycle becomes important. Now, these boxes with the thick red borders are the primary deliverables of those development phases. And the boxes in green are the various testing activities. And they need to be managed, and to be managed, they need to be measured. Now, I've laid out the testing activities in relation to the development phases where the testing activities are most appropriately performed. Half of proactive testing is doing the right things at the right time. This diagram shows that. The other half is how you do those things and using special powerful techniques, and we'll see those in remaining parts of the class. So traditional testing is reactive, unit testing, integration testing, system testing. It's reactive. It tends to come at the end, often reacting to the code that's been written. Many testers don't get involved, don't know what they need to test until the code is already written. By the time that the code is written, all of the defects are in the code. So the challenge is maximal. And ordinarily, by the time that it gets to testing, the project is already late. So your time is minimal. And because you're so late in the process, every defect is very difficult and expensive to fix. And because of that, traditional reactive testing, through no fault of its own, tends to be relatively inefficient and ineffective. It's better than nothing. And it's certainly, a lot of effort. People work hard at it, and they do find things. But they could be a lot more efficient and a lot more effective if they weren't working so far behind. Reactive testing is primarily dynamic testing, executing the code. When we get proactive, and proactive means anticipating, taking the initiative, we do things differently. Among other things, we also use static techniques. And as much as possible, we test the requirements, the design, feasibility analysis if you've got it. We use a variety of techniques to catch those problems before they become code problems. So most organizations either do not test or evaluate their requirements, or they use one or two relatively weak techniques, not realizing how weak those techniques are. Proactive testing has more than 21 ways to review or evaluate requirements. Now, we're not going to address them in this class. That's a separate course, but I just want you to be aware of it. And the more of those techniques that we use, and each one's a different CAT scan, the more of them that we use, the more issues with requirements we will find before they become design issues. So we make the requirements far better. If the requirements are far better, the designs will be far better. But it's not just that the designs are far better. We also have more than 15 ways to catch problems in the designs. Once again, most organizations use one or two techniques. We have more than 15. Each one's a separate CAT scan. The more things that we catch in the design, the better those designs will be. So we take far better designs and make them far, far better by catching more of the remaining fewer defects. Far, far better designs lead to far, far better code. If your testing does nothing different but the code is far, far better, your testing will be far better. The reason is because if you go back and examine the way that most testing occurs, most of what testing is catching are relatively minor, trivial defects, things that frankly never should have been in the code but are. When the code is far, far better, it doesn't have so many of those trivial defects. And what that means is that the more structured testing can be working on tests that ordinarily you don't get to carry out. And so what that means is that the code that goes through to acceptance testing is far, far, far better. But we don't stop there, because when we get proactive, we plan and design our tests as much as possible as part of the design phase before the code is written. And planning and designing tests before the code is written has two big benefits. First of all, it makes the tests that we're going to be executing far better, because we're testing what the code should do rather than reacting to what the code does do. And planning and designing tests, and we're going to be seeing this in later chapters, is one of our most powerful of our 15-plus ways of catching problems in the design. And so we're making the design far, far, far better, which makes the code far, far, far better. And we've got far better tests, so what goes through to acceptance testing is far, 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 far better. Hopefully that's understandable. But we don't stop there, because when we get proactive, we also do what's called proactive user acceptance testing. And most user acceptance testing is not planned or designed until right before it's executed. But when we get proactive, we plan and design the user acceptance testing up front for execution at the end. And when we do that, that tends to make far, far, far more thorough acceptance tests. We get additional benefits. There are two types of proactive user acceptance tests. Requirements-based tests, which demonstrate that the requirements have been met. And if you can't demonstrate a requirement, that indicates that the requirement is not testable, usually because it's not clear. So requirements-based tests help us catch requirements that are not clear or testable. But a requirement can be perfectly clear and perfectly wrong. And if a requirement is overlooked, testability is irrelevant. Now, unfortunately, in traditional reactive testing, the conventional wisdom is that testability is the big issue with requirements. In fact, it's only one of the issues. Now, the other thing that we do with proactive user acceptance testing is that we have what are called proactive user acceptance criteria. These are defined by the users, by the business, the stakeholders. It is the role of the tester to know that it can be done and to know how to do it to guide the users, not to be the one who defines the user acceptance criteria. Now, proactive user acceptance criteria offer us three benefits. First of all, they serve as a way to prioritize and structure the executable acceptance tests. Secondly, they help reveal requirements that are wrong and overlooked. And third, in conjunction with requirements-based tests and the business requirements, they are all input to the design of the system, to the design of the technical or development tests, and to the design of the executable acceptance tests. Because the executable acceptance tests really put together two pieces of information. What must be demonstrated to be confident that it works, and then how you use the system as designed to demonstrate it. So you need those two pieces. Now, when we provide the technical or development tests information on what the user acceptance tests are looking for, then we have the opportunity for the technical or development tests to anticipate and catch problems that otherwise wouldn't have been found, if ever, until acceptance testing or after. So what we're doing is enabling the whole development process to build stuff better, to make fewer mistakes, to catch the mistakes earlier, so that ultimately what gets built is we've got far, far, far better requirements, far, 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 far better designs, far, 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 far better code, far, far, far better tests, far, far, far better acceptance tests. And what goes through to production is far, 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 far better. And the good news is that it takes no longer and costs no more to get such better results, because we're using our time much more effectively. We're enabling the developers to do more right and less wrong. Okay, we're catching problems earlier when they're easier to fix. And this is an iterative process. Okay, we don't do whatever size piece of code we're working on needs to be responsive to relevant low and high level designs, which needs to be responsive to relevant requirements, which needs to be responsive to relevant feasibility strategies. whatever size piece we're working on needs to have the relevant testing done and do it in the appropriate ways. Now, there's undoubtedly a question about Agile. So Agile test-first development is a form of defining tests before the code, and that's a good thing. But I want you to realize that Agile is almost entirely sitting down here in the development coding quadrant. It really treats testing as an aspect of coding. And what Agile tends not to do is the planning and designing and the independent user acceptance testing. So out of this we get some key concepts. Find WIFMs, what's in it for me. We want to intertwine testing with each development deliverable. We want to plan before we act. We want to keep the acceptance testing separate from the technical testing. We want to plan and design during design as much as possible. We're going to do it in ways that promote reuse that we'll see later in the project, in the course. And we'll see how to prioritize level by level as we go. And out of this, we let testing drive development, which once again is not a political statement, it's a knowledge statement. We let testing information help the development process do a better job. And out of all of this, we enable the developers to do more things right and to catch more of their own problems. So the defect that can be fixed quickest is the one that's not created at all. The next quickest is the one that the developer finds himself or herself. We want testers, independent and professional testers who have greater skills and knowledge to be able to apply them more, to be double checking. Remember, Santa Claus said check it twice. Okay? And we want users to be double checking stuff that's been double checked. We don't want the users to be our main source of catching defects. So now I know that we've covered a lot of information tonight, okay? And here's the exercise for those of you who are going to be continuing with us on Monday, and I hope you all will be. Here's the exercise that I would like you to do. So I want you to think of where people might have resisted testing and see if you can identify any reasons why they might have resisted it. How was the testing presented to them? Was there a WIFM, a what's in it for me? And if there was it for the people who resisted, or was it a WIFM for the testers? And then see if you can figure out how things might have been done differently so that they might have seen a WIFM that would have caused them to say, oh, I want to do this because it will save me my time, my effort, my aggravation. So hopefully this is understandable. And so we've got time for questions here. If you have questions, please chat them to me, and I will endeavor to answer them as best I can. And while you're chatting, I'll just remind you that this is the last of the free sessions, that if you want to continue for the remaining 9 sessions, which can be live and or recorded, that is, we'll be presenting them nightly, 1 hour a night, like these sessions this week, starting next Monday. And in order for you to get the access to that, you're going to have to pay the fee. And as we said, the fee is $350 for access to the recorded videos, and an extra $50 if you would like to attend the live session so that you can ask questions like this. Okay. So any questions, please chat them, and I'll do my best to be as responsive to you as I can. Anything that anybody wants to ask about? Anything that's not clear? Anything you'd like me to confuse further? Okay. So let me raise a couple of points here. That first of all, testing, whether it's reactive or proactive, is an important way for the organization to reduce risk and to catch defects before they get to users. As I've suggested, traditional reactive testing, and lots of people work very hard at it, and my hat is off to them because they're working under difficult circumstances in many instances. Traditional reactive testing is often not as effective or efficient as would be desirable. When we get proactive, we become much more effective. We can accomplish much more, catch many more problems, help the developers develop not only better, but also quicker and cheaper. And all of those tend to be WIFMs. Okay. So we have a question here. Is this course good for beginners? Absolutely. Absolutely. And I'm glad that you raised that because we're talking about testing concepts and techniques, making no assumptions about what you have already done or have already studied or already know. Sometimes people who have been working in testing the longest have the most to learn because they've picked up a lot of practices along the way that sometimes warrant unlearning. So I'm making no assumptions, and I'm trying to present this in as understandable a way as possible. And frankly, beginners sometimes understand these concepts better than people who keep trying to squeeze them into the practices that they're already familiar with. And by the way, many of the concepts and techniques that we're discussing are identical to those that traditional reactive testing uses. But we're applying them in ways that are more powerful, more effective, and hopefully with some greater insight. So we'll point out some traps that people fall into that they're often not familiar with. So good question, and we welcome beginners. And you know, the fact is I work with a lot of testers. I teach a lot of testers. And it's very common when I ask testers in one of my courses what courses they've taken previously on testing, probably the most common answer is that they've never had any formal training on testing. So my course is often the first course that somebody has. So indeed, we're aimed for people who are beginning, but I think you'll find that if you've got 20 years of experience that you're still going to find an awful lot of important stuff. So excellent question. Anything else anybody would like to know? Okay. What is the advantage of choosing this testing? Okay. Well, first of all, as I said, testing itself is a valuable and valued activity. Most organizations have recognized that testing is a role in and of itself, and you know, they reward testers, they rely on testers to catch defects, to help them deliver software that works properly. As I've also indicated, testers tend to be in an awkward position. A lot of testers don't get involved as early as they should, that don't have as good information as they need, and because of when they get involved, their effectiveness is limited. When we get proactive, we use methods that help anticipate things. And so you're less a prisoner of the tail end of the process. And so in my experience and my perception, proactive testing, when you understand and apply these proactive testing techniques, you are a more effective tester, you are a more valuable tester, and because we use methods that other people can recognize and appreciate, we are more valued testers. Now, you still have to do the work. You can't just go in and say, hey, I took this program, a bunch of nights in March, and so give me $1 million. You have to apply the concepts. You have to learn and apply the concepts, but I think you're way ahead of the game. Okay. Let's see. Does the course delve into using any tools and their appropriateness for test levels, or is the course more instructional on the process of testing? Excellent question once again. And let me answer that in with regard to a couple of aspects. The first thing is that this class is on the process of testing, how you identify what the tests are that you need to carry out to give you value, and how you identify them and then prioritize them based upon risk, because testing is our primary means of controlling risk in software. Having said that, a lot of people get tools and don't get value from those tools. And the reason is because practically every tool vendor will tell you, and usually in about these words, that a tool is only as effective as the testing process in which it's used. Now, I've found that if you ask that tool vendor what that means, they don't know. It's only a phrase that they've learned somewhere. But I'm going to tell you that your testing process is the means by which you identify what you need to demonstrate to be confident it works. So your testing process is how you identify what the tests are that you need to run and which are the most important ones. And then there's another thing that follows from that. Once you've identified which are the tests that are most important to you, then you need to further analyze and say which of those tests are good candidates for automation, because there are many tests that are not good candidates for automation. And if you spend time automating them, you're actually working against yourself. It's being counterproductive. So identifying the appropriate tests, the most important tests, is the first most important thing. The next thing then, if you have tools, is to pick for those tools only the tests that are good fits. And a lot of folks find that when they get tools, the tools actually interfere. Now, here's another answer, and that is that IT eLearn presents a lot of training on particular tools. And so to a considerable extent, tool training is specific to a particular tool. There are certain general categories or types of things that particular types of tools do. But if you're learning how to use a particular tool, you have to learn with that. It wouldn't be applicable to somebody who had a competing tool, for instance. So kind of a long answer to a short question. Hopefully that's understandable. Okay. So, okay. So let's see. We've got a, let's see if we've got any more questions here. Okay. There are lots of testing methods. What is the advantage of choosing this testing? I think you will find that practically any book or course on testing, except ones that are simply directed toward the tools, but ones that are on the testing process, the testing techniques, I think you will find that practically every one of them generally describes a number of techniques for designing tests. Boundary tests, equivalence classes, decision tables, and so forth. Okay. And that's a good thing because each one of those represents a different CAT scan, a different way to identify things that you might not have identified with a different technique. So, and some people are more comfortable with one technique than another. Some situations are more amenable to a particular technique, and so forth. So all testing training tends to concentrate on describing, giving you practice and familiarity with a variety of techniques for designing tests. In my experience, the other courses tend to simply treat testing as a bunch of individual techniques. Here's a technique, there's a technique, here's another technique. And what they tend not to do is have an organized approach. And this course has an organized approach to applying those techniques. This course also looks at those techniques a little bit more critically and identifies some traps and pitfalls with them so that you won't fall into them. Now, the other thing that happens that's different about this course is that we also have a whole bunch of additional techniques, additional approaches, things that traditional reactive testing doesn't know about and is not taught in traditional courses. So these additional methods are really very powerful. Things like helping us avoid showstopper errors. Traditional testing does not avoid showstopper errors. How do we know? Because they occur. Okay. Largely because A, is occurring too late, and B, they just don't know about these other methods because they're still working on the same old, same old. I'm not saying what they're doing is wrong. I'm just saying that it's not the full story, and we have a number of additional, more powerful approaches, not the least of which is our emphasis upon things that win support from users and developers and managers, the WIFMs. So in my perception, we are just presenting a whole lot more valuable information. It makes you a more valuable tester, and it can make you a more valued tester. So hopefully that's understandable. Let's see. Any other questions? Anything else that anybody would like to raise? Well, these were very good questions. I appreciate your asking them, and I hope you have found this helpful. I think you'll find that this is just the beginning, of course, and that we have 9 more hours of classes to go into explaining and showing you all of these things that I've been talking about. The approaches, ways to avoid and prevent showstoppers, ways to gain support from users and managers and developers. So I hope that I will see all of you next Monday. You need to go to ITE Learn's site to sign up for the course, arrange for payment, and if you're not coming back, hopefully you will have found some things so far that you can begin to get some help from. And I wish you good luck with that, and hope to see all of you next Monday. So thank you very much, and we'll be signing off now.